Now, the curl of a vector field. This is nothing but the cross product between the del operator and some vector. Because it is a cross product, we close this particular operation with square brackets. That means the output is also a vector. So generally speaking, suppose if I take example of vector A cross vector B, cross product, and if my vector one vector is suppose say 2i cap plus 3j cap plus 4k cap, and b is equal to 6i cap plus some 7j cap plus 3k cap. So this is my general notation or an example I'm taking. If I want to do A cross B, which is a cross product, how do we do with such problems? You know, when I say it is a cross product, we take the simple determinant. It is nothing but a determinant of something and with something. So how do I mention the determinant? So let us see the determinant portion of this. Okay. The answer is, that means the resultant vector should be the determinant of I cap, j cap, and k cap. So first vector, what are the positions? 2, 3, 4. Second vector, 6, 7, 3. From this place, I think to solve this, how do we find determinant? So I cap into 3 into 3 minus 7 into 4. Of course, I don't have to do it. Minus j cap 2 into 3 minus 6 into 4 plus k cap 2 into 7 minus 6 into 3. So this is further reduced. Now what we have? L cross V vector. There are two vectors. So two vectors and cross product. So this is what. First of all, let us define what is del. Nabla operator. This is a vector. Delta 1 dou by dou x1 plus this is a vector. Delta 2 vector dou by dou x2 plus delta 3 vector dou by dou x3. So this is one vector. V vector, yeah, this is also a vector. So this is delta 1 v1 plus delta 2 v2 plus delta 3 v3. So there are two vectors defined in terms of Kronecker delta. Now the cross product. The cross product of these two inclusive square brackets would be a determinant. So this is delta 1, delta 2, delta 3. So what is the quotient of delta 1 in first vector? Dou by dou x1, dou by dou x2, dou by dou x3. Next one, b1, b2. If we can solve this, our problem is over. So how do we solve this? Delta 1 vector into dou by dou x2 v3 minus dou by dou x3 v2 minus second column when you take minus dou by dou x1 v3 minus dou by dou x3 v1. plus third one tau by tau x1 b3, sorry, p2 v2 minus tau by tau x2 v1. Hope you are able to understand what I am trying to write in this particular place. So what will happen is delta 1, so you can write like this, tau v3 by tau x2 minus tau v2 by tau x3 minus, this is again a vector, like tau v3 by tau x1, tau v1 by tau x3 plus third component. See, remember these brackets what we are trying to write now. Tau v2 by tau x1 minus tau v1 by tau x2. I think this is the resultant of the total product. So curl of a vector. This one, we can write this as tau 1, tau v3 by tau x2 minus tau v2 by tau x3. This one I make it as plus. I can write this as dou v1 by dou x3 minus dou v3 by dou x1. Be careful here. Okay, we need to be careful here in this particular item. Okay. Wow, this is something great. So this can be del cross v. This can be generalized and written in the form of J sigma k epsilon I j k. So tau by tau x j. This is the ith component. No? Ith component means I can write like this. So the ith component is something like written like this. Generic form. Totally what we can write. That means if I'm totally writing sigma I, sigma j, sigma k, we write it as epsilon I j k delta I dou by dou xi. This, how do we get it? This is again from the properties. We should be in a position to re-verify. So I have taken a simple method to actually come down. But if I go with the principle, that means definition of the Kronecker delta and all, we can also do that. Okay. That means we need to understand the delta I cross delta J. What is the answer? Delta J cross delta K. Delta K cross delta I. But of course, it's a cross product, so you need to have like this. Okay. So, by definition, by definition, what would it do, right? So, if I just go by the definition of the cross product of the Kronecker delta, you have scalar product, cross product of the Kronecker delta. See, these all derivations we are now still restricting only to the Cartesian coordinates, but if you have to write in cylindrical coordinates, we should be in a position to write. So generally, The notation what we write, see, delta I cross delta J is sigma k is equal to 1 to 3 epsilon I j k delta k. This is how we can write. So similarly, if I come to this place, sigma, there is no I. So I is equal to 1 to 3 epsilon I j k delta I. Now if I come to this, sigma j is equal to 1 to 3 epsilon I j k delta j. We have something called delta. I just happen to write delta 1 cross delta 1. This is a vector, this is a vector. Square product should be equal to what? 0. Delta 2 cross delta 2 is 0. Delta 3 cross delta 3 is 0. Okay. See, by these results only, this generalization has come. Now you have delta 1 cross delta 2. Okay. If I write like this sequentially, that means in a cyclic manner, if you do that, this becomes delta 3. So going ahead, delta 2 cross delta 3, delta 1. Delta 3 cross delta 1 would be delta 2. But if we write in the reverse fashion, that means if I write this as delta 2 cross delta 1, this is not plus delta, it is minus delta. Here, delta 3 cross delta 2 minus delta. Here, delta 1 cross delta 3 minus delta.